Hello statistics student, this video is for chapter 8.2, confidence interval for mean when sigma is not given. So a lot of times we do not know sigma, so although X bar is normally distributed, in the past we say, well, we can do tick mark and then figure out what the tick mark would be for a certain confidence in a confidence level. So because each of these is sigma over square root n, so we will base on z to find the number of tick mark. But if this is not given, so we'll say each tick mark now is s over square root n, and so these tick marks are now modeled by t, okay? Instead of z is now modeled by t. So this is x bar, and each tick mark is 0, 1, 2, 3, but this is a t number, not a z number. So we solve that problem. The second problem that we might run into is we have a very small sample size, but we actually do not know if our population is normal, right? So like this is a example where we have some measures of arsenics, some bad minerals in the brown rice from California. We only have a samples of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sample. It's not greater than 30, but we don't know if arsenic is normally distributed, right? If it's normally distributed, that's good. That means X bar should be normal. If it's not, then we need a bigger sample size. So this is actually the same problem that the person that discovered or the introduce, or I don't know if it's discover or introduce t distributions runs into. The person is William Gossett from the UK, and he had information that he need to process where he doesn't know if the population is normally distributed, but he has a very small sample size. So and then he will figure out that, okay, if I want to use S over square root n, I need to make sure that my data is normally distributed. So we learn in chapter 7 that to understand if a sample is from a normal population, what we can do is put this data and then do a normal quantile plot and a histogram, right? So that's what I'm going to do. I have typed my data in the Excel spreadsheet, copy it, and I haven't started to do confidence interval yet, so clear all this, paste in, Control V, paste in here. I just want to make sure that I can actually construct a confidence interval by analyzing the data. So 2, right? So do a normal assessment test. Yeah, normal assessment 2. Normality assessment, so I see that there is no outliers. Is this kind of normal? It's okay. There is one peak, and then there's these two that is, on the two sides, so it doesn't deviate from a normal distribution that much. The lines are, except for the last one, they're pretty close to a straight line. It's not like fluctuating or any pattern. So we can roughly say that it is from a population that is normal. So especially if you have a very small sample size, sometimes you do not get like perfect data. In reality, data are not perfect. So we say data are reasonably close to a straight line, so we can assume that population X is normal. That is the case, then we can use t distribution to calculate the margin of error. So we say construct a 90% confidence interval of mean arsenic in all brown rice in California. What distribution is used? We would use t distribution because sigma is not known. As a matter of fact, because we have data, we only need to know the sea level. So we identify sea level will be 0.9. We put the data in the column 2, and we'll run the confidence interval mean, but use data tab. Okay, so I'm going to I did it before when I was doing the notes, but we're going to do it again. Oh, it's this one. right? So I have my data mean one sample, and my data is in the second column. I want 90, is it 90%? I want 90% confidence interval 0.9. So that is all I need to give. I do not have population standard deviations because I'm using t. So evaluate. So this is the error. Error is 1.3347, and the lower cynic is 5.002 to 7.698. So around to 698, right? So I have it here. The interval estimate is from 5 to 7.7. Okay, if I round to one decimal place, and then so this is the mean arsenic level is from 5 microgram to 7.7 microgram. Okay, what is the critical values? Because we're using t distribution, so we'll do inverse t. So let's do inverse t. And then my degree of freedom is n minus 1, the sample size minus 1. My number of data is 10, right? Because I count the number of data I have is 10. So my degree of freedom is 9. So I put 9 here. And I'm doing a 90% sea level. So my tick mark is 1.833. How come I get 3 points? So it's 99, yeah, 1.833. This is wrong. I'll update the notes. I wonder if it's because I didn't change it to maybe I do 99%. Yeah, if it is 99%, it's 3.25. Because I'm doing 90%, it's 1.833. Okay, because it's closer to the middle. D. So we will use whatever that we have learned about interpreting the meaning of confidence intervals. Interpret the meaning of the confidence intervals. We say the arsenic mean is 5 to 7.7. How do we say it? We say that we estimate with 90% confidence that the mean amount of arsenic for all brown rice is between 5 to 7.7 microgram. Or we can say 90% of all confidence interval collected from a sample of size 10 will contain the true mean arsenic. So if we do these intervals again and again by doing a lot of samples, 90% of all those will have it. So we have only one, so we don't know for sure, but we are 90% confident that it is between this. So now the last one is to make conclusion. Can we conclude the mean amount is less than 8? Let's say 5 to 7.7. Are all of these less than 8? Yes. 5 to 7, if you draw the number line, 5 to 7.7. Any of these could be the meal. So we can say that with 90% confidence, we can say they are all less than 8. 8 is here, right? So all these numbers are less than 8. So we are at 90% confidence that the mean value is less than 8. So that is all for 8.2. So we'll do 8.3 for confidence interval for proportion.